All right, so last topic we're going to look at in the class is logarithms. Okay. Logarithms are something you would use just to kind of show you an example. If you had a problem like this, it's not a super long equation. It just says 2 to what power would give you 12. Well, the problem is if we try 2 to the third power, what's 2 cubed give you? Marcia? 2 times 2 times 2?
6. Unless it's too early in the morning.
It's too early. Anyone help her out with 2 times 2 times 2? 8. So 2 to the third power gives you 8. How about 2 to the fourth power? 16. Well, we skipped over 12. So 2 to the third power is too small. 2 to the fourth power, too big. So the answer is somewhere between 3 and 4. Okay, what is the exact answer? Well, that's what a logarithm would tell us. All right. So by the end of the week, you'll hopefully be able to solve that. So the thing that I just showed you is an example of an exponential expression. If you look at the first few letters in there, it kind of looks like exponent. And an exponential expression is basically anything that has a variable as an exponent. Okay. It's a little harder than if you had something like this. Okay, in Algebra 1, that's a pretty straightforward problem. 2 times x equals 12. Just divide each side by 2. But once you make that x an exponent, then the problem's not quite as easy. Okay. So that's not a problem you would see in Algebra 1. There's a couple more examples, just like the ones I wrote on the other page. Okay. Technically, what I put on the other page is an exponential equation. Okay. These are exponential expressions. What makes something an equation? What do you have to add to it? Yeah? Equal sign. Okay, so that's an exponential equation. This part right here is the exponential expression. So the way you can solve an exponential expression is to change it to a logarithmic expression. So we're going to practice changing back and forth between the two. Okay. I call exponential form and log form. Okay. And I'll show you the formula right now. So when you had something in log form, or we put it in exponential form, there's basically 3 things in the equation, no matter which way you write it. So if you're translating from exponential to log form, you got to figure out where do the 3 things move, okay, when you go from one form to the other. There's no calculation, there's no arithmetic. It's more of just a visual thing, like where do they go when you rewrite it. So on the left, what I have right here, that is an example of something that's an exponential equation. X equals a to the y. Now, if you're going to solve something like that, you've got to have some numbers in there. Okay, so maybe, a and y would be numbers. So if it was something like x equals 3 to the second, then you could solve it. Okay, but for now, nothing is going to be numbers. This part is your base, right? Because the base is what's written lower. The number that's higher, that's your exponent. Okay? And then the x is just what it's equal to. That's just the thing on the other side. So those are the 3 things that are going to go in different spots. And when you change it to log form, the first thing you have to do is write the word log. Now, before I even explain that, I just want to be kind of clear how this is written, like if you were writing this on line paper. On the right-hand side, where it says y equals log, there's an a and an x, there are no exponents on that right-hand side. Okay, no exponents at all. Some people think, wasn't the x an exponent? No. If you were writing that on a line paper, you have y equals log. The a is actually a subscript. Okay, it would be below the line. The x is right on the line. If you wanted an exponent, it would be up there. The 2 is an exponent. Okay? Now it's x squared. But that's how you would write it on line paper. And then I'm going to go over how to pronounce that in a second. Okay. And if I explain how to pronounce it, that's going to tell you where one of these things goes right away. Because remember what I called a. It was the number that was lower. Jamaica, what do you call a again? The number that's lower? It's the one below the exponent?
Not sure.
Yeah?
The base.
The base. So the way we pronounce the right-hand side is y equals log base a of x. So if you can remember how to pronounce it, it'll tell you where one of the 3 letters goes. A was the base on my exponential expression because it was lower than the y. And a is the base on my log expression because it's also lower than everything else. Okay, so that's where the first thing goes. The base on the exponential becomes the base on the log. Okay. The next thing, okay, I'm just going to put this off to the side. Logs always equal the exponent. Logs always equal the exponent. That's the point of a logarithm. A logarithm is used to calculate an exponent. And that's what I tried to show you right here. If you wanted to know the answer to that problem, you would use a log. And it would calculate what the exponent comes out to. So just try to get that sentence memorized in your head. Logs equal exponents. Logs equal exponents. So logs always equal exponents. So whatever the exponent was, that goes by itself on the other side. Now, once you figure out where 2 out of 3 of them go, there's only one spot left, and there's only one letter left. X goes right there. X is what you're taking the log of. It's kind of what you're plugging into the log function. Okay, kind of like if I said this. 3 is what I'm taking the square root of. It's what I'm plugging into the square root function. 3 is what I'm plugging into the log function. Okay? And the base, we'll talk more about the base in a little bit. So there's different kinds of logs. You can do log with any base you want. Base 2, base 5, base 6, base 7, base 8. You know, as much as you want to do. For now, we're going to eventually have to learn how to type it into a calculator, but for now, we don't have to worry about it. So any questions on that formula? And I put an arrow going each way because you can change what's on the left into what's on the right, and you can change what's on the right into what's on the left. Okay. Generally, whichever way they give you the problem, you write it the other way. That's how it kind of works. All right, so let's try an example. So they're asking me to change something to an exponential expression, which means they're probably going to give it to me as a log expression. Now, the letters that I used, think of them, they're just placeholders. Okay? You might see, if I go back for a second, other letters besides X's, A's, and Y's. You might see M, N, you might see other letters. But don't get too hung up on the letters. Try to get hung up on where the letters go. Okay, so let's start with the 3. Lexi, do you remember what we called the 3 because it was a little bit lower than everything else?
The base.
It's the base. So when I rewrite it in this format, okay, I'm looking for something that's going to look kind of like that when I'm done. The base is going to be my 3. Right. Brady, what did I say? I wrote it off to the side with an asterisk. Logarithms always equal the... What do we use logs? Remember that equation I showed you earlier? And I asked Marisha what's 2 to the 3rd power? It was too early and all that. Maybe it's still too early, I'm not sure. But remember what we were solving for? Anyone help him out? Yeah?
The exponent.
Exponent. Right? We looked at an example, and I said logarithms are used to solve for exponents. And then we wrote it down. Well, some of us. Logs always equal the exponent. Okay, so always remember that. So now I look here. The logarithm equals, there's your exponent. So now you've used the 3, you've used the y. Lauren, what's the only thing that's left?
Oh, the x.
The x, and that's going to go on the other side. And that's all you can do. Now, that's not something you can solve. If you were going to solve that, you'd have to know y. Then you could do it out, like y. If y was 2, it would be 3 to the 2nd power, and the answer would be 9. Okay. So at this point, you're done. Okay. Any questions on that one? All right, let's try this one. Okay, let's try to read that off first. Okay. Anyone think they can pronounce that for me properly? What that says?
Y equals the log base 5 of x.
Yeah, you read it left to right. You just have to make sure you say the word base, so the person knows when you're reading it, 5 is the base. Y equals log base 5 of x. Great. So she already told me one of my 3 things. 5 is the base. So that's going to go lower. Now I need an exponent on the 5. Ethan, what's my exponent going to be?
X. Y.
Y. Remember, logarithms always equal the exponent. Okay. So we've got the 5, we've got the y. The only thing left is x. And that goes on the other side. Any questions on that one?
So like we put it in that form, are we like trying to solve anything, or are we just keeping it like that?
Just keeping it like that until we've got some more numbers, and then we can actually solve. So for now, we're just going to practice changing to exponential form, and now we're going to practice changing back the other way to log form.
Cool.
All right, so this one says 1.2 cubed equals m. So Sam, if I'm going to put this in log form, what do you think the very first thing I have to write down is, so somebody reading this knows we're dealing with a logarithm?
Log.
Yeah, you got to put the word log. Exactly. So put the word log. Okay, and when we're done, we're looking for something like this. I didn't really tell you the name of this other thing. This is the base. This thing is called argument. Okay? And arguments aren't really something new. Okay, we've seen them all year. The argument is the thing you're plugging in. So like if I said to you the sine of 12 degrees, 12 is the argument to the sine function. It's the thing you're taking the sine of. Okay? Well, this is the thing we're taking the log of. All right. So let's start with my base, okay, on my log. Luke, what's my base going to be?
1.2.
1.2. 1.2 is the base for the exponent of 3. 1.2 is the base for my logs. Ryan, we said earlier logarithms always equal what kind of number? Exponent. What's my exponent in the original problem? 3. So that's what my log is going to equal. Now we've used the 1.2, we've used the 3. The only thing we haven't used is the m. And that's going to be the argument to my log function. And that's it. So again, at this point, we're not solving anything. We're just rearranging from log to exponential. What we're doing right now is going to be the first step when you have to solve a problem. Okay. All right, let's try this one. E to the b equals 9. Okay, so Pacey, I'm going to write this in log form. First thing I should put down, put down the word log. Okay. Sean, what's my base here?
E.
E. E is the thing that's below the letter. So E is going to be the thing that's below the word log. E. Okay. Kyle, logarithms always equal what kind of number?
A variable.
Can you be more specific?
Y.
Not quite. Brady, can you help us out? Exponents. Right? Logarithms always equal exponents. Okay. Make sure we write that down. So my exponent in this case is b. So logarithm equals b. Now, the only thing I have left is the 9. Does anyone remember what I just said you call that? It's the argument to the log function. It's not an exponent. It's right on the line. E is below. Okay. Any questions on that one? All right. Does anyone need to see another one changing to log form? We did 2 one way, we did 2 the other way. I had a third one, but if you wanted to do that one, it would be 4 equals log base a of 24, if you did it out. All right, so let's try one more now. Now we've kind of gotten used to doing it one way. Let's go back the other way one more time to see if we remember that. Okay, Alan, what's my base here?
E.
Yeah. E. And now I need my exponent. So Kyle, logarithms always equal what kind of number?
Exponent.
Exactly. -3 is your exponent. And the argument, the b, just ends up going by itself. And there's your answer, e to the -3rd. Now, we're going to talk a little bit more about e in a second. Well, probably like 5 minutes. But e is actually a number. Okay, just like pi. Pi looks like a letter. It is a letter in the Greek alphabet. But in math, that Greek letter means something. It means what I just put on the calculator. Well, e in the English alphabet is a letter. But in math, e stands for something special. 2.718. So I could actually do this out. I could put in e, e raised to the -3rd power. So there is actually a decimal answer. B is 0.0498. Okay, I don't care what e is right now because that's not what the direction said to do. But I'm kind of just hinting at the idea that we're going to start talking more about the number 2.718, which is called e. Did anybody remember that or talk about that before when, yeah. If not a huge deal, we'll talk about it. Okay, so this is a problem where the directions could say solve. Okay? It says find the exact value. You know you're solving because you only have one variable. Okay? You couldn't solve the other problems, like the ones we started out earlier, because they had 2. This only has 1. So Abby, is this an equation that's in log form or exponential form? It's in log form. If you see the word log, it's log. Generally, the first thing you want to try to solve it is change it to the other form. Okay? And Cassandra, do you remember the name of the other form? We've got log form and what's the other one?
Exponential form.
Yep, exponential form. Okay, so let's change it to exponential form and see if we get something we can figure out. How about Colby? What is my base here?
2.
2. So my base is 2. Carissa, how about my exponent?
Maybe 16. I mean, no, x.
X, right? Logarithm always equals the exponent. So the argument ends up by itself, just like it did in this one. The argument ends up alone. Think if you argue, you're going to end up alone, right? People can get annoyed with you. So the argument ends up alone. Now, I picked these numbers because this is one you can do in your head. Okay, if I made that 16 a 17, you couldn't do it. But we should be able to get this one. 2 to what power gives you 16? 4. Yep. So for now, I'm going to give you a number like 8, 16, 32. Okay? I'm not going to give you one like 2 to the x equals 12. Okay, we're not quite there yet. Okay, any questions on how we figured that one out? All right. So let's try this one. It says log base 5 of 25 equals x. Now, after you've done a lot of logs and you get used to them, you really don't even need to do this step. You can kind of just look at it in your head and say, oh, 2 to what power is 16? This is basically saying 5 to what power is 25. Okay. But if you want to write it out, 5 is your base, x is the exponent, 25 goes on the other side. So Emma, what would x be here?
2.
2. So any questions on those? Those are our first 2 problems we've solved with logs. You don't need a calculator, but eventually there'll be some you do. All right. Let's try this one. Okay, same kind of setup. You know the base. You know the argument, and the variables on the other side. Right, so Ben, what's my base here?
3.
Yep. My base is 3. Okay, Austin, how about my exponent? X. So that means the fraction, the argument, is by itself. Now, if you get stuck on that, because it's a fraction, in your head for a second, just think of this problem. Instead of thinking 1 over 27, pretend it was just 27. Now, the answer to the one on the right and the one on the left, it's not the same answer, but they're very close. 3 to what power would give me 27? Yeah, 3 to the 3rd power. So for this problem, x would be 3. But here, you don't want to get 27. You want 1 over 27. You want it to flip. So does anybody remember what kind of number you need for an exponent that causes you to get a fraction? Yep, Ethan?
Negative.
A negative. So the answer here is negative 3. Okay, so anytime you want to get a fraction, you've got to have a fraction specifically less than 1. You've got to have a negative exponent. So really, just focus on the number in the bottom. 3 to what power gives you 27, and then make it a negative. Okay. Any questions on that one? All right. So E, okay, I kind of already mentioned this earlier, but E is a number. Okay, when you talk about logs. In Algebra 1, it would be okay to use E as a variable because in Algebra 1, students don't really know this. But once you get to like Algebra 2, trigonometry, pre-calculus, and calculus, you would never want to use E as a variable because it's not. E has a special value, 2.718. Just like I would never use pi as a variable in math because it already stands for something. You're going to have to figure out on your calculator where your E button is. On mine, I have to press second E. Okay. On my calculators, I can show you. Does anybody have one that's similar to mine? I could borrow. Actually, can I see yours for a second? So on these calculators that look like mine, the E button is you press second, and then it's the third button down on the left-hand side. It says LN. Okay, so second and the third button down, it says LN. And that's your E button. So anytime that you have a base of E on a log, like we had, where was it? Back here. What I just circled, okay, what I just pointed to, you would never see that written. Okay, that's not normally something people write. Okay, just like that's not normally something people write. If you want to take the square root of 9, not what I had before was wrong, but you usually write it this way. Well, anytime that you have log with a base of E, they use an abbreviation for it. Okay? That's lowercase l, lowercase m. So this gets abbreviated as that. It's not like it saves us a ton of time. I mean, log base E, that's only 4 letters to write. ln is 2 letters, so I guess it's half the number of letters to write down. But that's how they write it. That's also how you're going to see it on a calculator. If you look at this calculator, or yours, you're not going to see a log base E button. What you're going to see is an ln button. Right, so you just have to know that ln is the abbreviation for log base E. Okay, what's a little tricky about that is when you write it with the lowercase l and n, look what happens to the base. It gets hidden. Okay, it's there, but it's hidden in the abbreviation ln. Okay, so you just have to remember, all right, if I see ln, the base is an E, even though it's invisible. Okay, it's hidden. Okay, and if you're kind of wondering, well, where does this ln come from? Like, why did they pick those 2 letters? It's because whenever you have a log base E, that's called a natural logarithm. So why did they do NL instead of LN? I don't know, but that's what they did. So there's only 2 logs that we study that have special names. One of them has a base of E, and it's called a natural logarithm. The other one, I think we're going to get to, yeah, we'll get to in a little bit. So any questions on that abbreviation? That's all it is. ln is just an abbreviation. let's do the same kind of thing we did before. Let's change this to an exponential expression. Okay, now if I look at that quickly, if this was on line paper, I don't see anything below the line. There's no base written there. But we have to remember the base is hidden. And what is it?
E.
It's E. So if the first thing you want to do is replace the abbreviation with the long way of writing it, we can do that. Okay, now from here the problem should be just like the past ones. Okay, so we just said our base is E. Liz, what's my exponent?
8.
Yep, logarithm always equals the exponent. So e to the 8th equals x. Now the directions didn't say solve for x, they just said write it as an exponential expression, and I did. But if I wanted on my calculator, I could type that in, e to the 8th power. Any questions on that? All right. That's another one that's pretty much the same. So that would be e to the 12th equals x. Okay, if you want to practice that on your own, you can, but it's exactly the same as the last one. All right, so I said to you that there's two special logs, or two logs that have special names. Base e is one of them. The other one is base 10. Since base 10 is used a lot, it's the most often used base when you're dealing with logs, they call that the common log. So there's an example of a common log. So you could pronounce that log base 10 of 5. Or if you said to me, take the common log of 5, I would know what the base is because you said common log. If you said to me to take the natural log of 5, I would still know what the base is. Okay, that's e. This is 10. You could also write it like that. What do you notice about the way I wrote it, the second log versus the first log? What's missing?
No base.
Yeah, there's no base. If you don't put a base, it's kind of like in algebra when you don't put a number in front of x. We know that there's something there. We assume there's something there, right? Well, if you don't put a base, we assume that it's 10. All right, so if you just said to me log 40, I would assume that you're meaning base 10. If you didn't want base 10, then you have to tell me the base. And those are also the only two logs that the calculator can do directly. Okay. So if I wanted the log of 40, there's a button for it. On my calculator, it's 6 buttons down on the left-hand side. I pressed log, and I could type in 40, and I get an answer. Now remember, that 1.6, that's an exponent, right? That's what happens. When you press log and type in a number and hit enter, the answer is an exponent. That's what you're solving for. What is it an exponent on? Well, whatever the problem was. Okay? But 1.6 represents an exponent. If I type in ln of 8, that's another exponent. Okay? The top one is base 10. The bottom one, base e. Okay? If you want to do a base other than 10 or e, well, what if you wanted to do log base 7? Okay? There is no log base 7 button. Okay? They can't put a button for every single base because the base could be any number you can think of. So there is a way to type it in. When you have a different base, we're not going to look at that until tomorrow. All right, so we'll finish up with a few more log equations. So this says log base 3 of, and that whole thing in parentheses, 4x minus 7. You don't need parentheses. I put them there to make it clear to you, but that's all the argument. And that equals 2. All right, so what's the only thing that we've learned so far? When you have an equation that's written in log form, what can you do with it? Yeah?
Turn it into exponential form.
Exactly, turn it into exponential form. If that doesn't work, at this point we're stuck, okay? Because that's the only trick I've shown you. So Caitlin, what's my base there?
3.
Yep, my base is 3 because it's lower than everything else. Alan, how about my exponent?
2.
2, yep. Logarithm always equals the exponent. And then remember the argument. If you argue, you're going to annoy people. You end up by yourself. Argument ends up by itself. 4x minus 7. And now from here, this is just an algebra 1 equation. So now we just finish solving it. Okay, so square the 3. Lexi, my next step to get x by itself. Add the 7. So we get 16 equals 4x. And Ethan, my last step. Divide by 4. So I get x equals 4. Okay. Questions on how we solve that one? Okay, so that's a log equation where the variable was in the argument. Okay, it's inside the argument. Let's look at an example where the variable is the base. So this is log base x of 64 equals 2. Jamichael, what kind of equation is that? Log form or exponential form?
Log form.
Yeah, it's in log form because it's got the word log. We're going to change it. Don't worry about how to solve it yet. Just change it and then look at it, and we'll see if we can figure it out from there. So Tanner, can you rewrite that in exponential form for me?
The base would be x.
Yep, base would be x.
2 would be the exponent.
Yep, 2 is the exponent.
And that equals 64.
And the argument goes by itself. So x squared equals 64. Okay, so now how do I solve that for x? How do we get rid of squaring? Take the square root. Square root and square root. Now, normally when you take a square root, you get 2 answers. Right? 8 times 8 is 64. Negative 8 times negative 8 is also 64. But when we're dealing with logs, you cannot have a negative base. Okay? If you do, you're going to get into imaginaries. Okay? Same thing with the argument. You can't take the log of a negative number. Well, you can, but it's imaginary. Okay? And we're not doing imaginaries. So for our purposes, we'll just say you can't do it. Make sure your base and your argument are always positive. So don't write positive or negative 8. It's just positive 8. Okay, so that's an example solving where the variable was in the base. We did the argument. Let's try one like this. So what's a little different about this one is now it's an exponential equation. So we always start out by changing it to the other form and then go from there and see what happens. So Pacey, could you change that for me to the to log form?
2x equals ln, and then 5
Yeah, so he did two things at once. Remember, this e is your base. So if you're thinking, well, shouldn't it be log and the base is e of 5? Yep. If you thought of that as the first step, that's good. But remember, log base e is abbreviated as ln. And now there's just one step left to get the x by itself. So Justin, how would I finish this up and get that 2 over on the other side?
Divide by 2.
Yeah, just divide by 2. Divide by 2. So the exact answer to this problem is the natural log of 5 divided by 2. If they wanted an approximate answer, you take the natural log of 5, divide by 2, and you get about 0.805. Now what we could do is check it. Let's take e to the 2x and see if we get 5. But now I know x is 0.805. So let's take e raised to the 2 times and fill in x. 0.805. I got 5.00. I was supposed to get 5. How come my answer is a little bit off? What's a little bit off there? Yeah, I rounded. The exact answer is not 0.805. That's a rounded answer. Okay, but since I plugged it back in and it's pretty close to 5, which is what it was supposed to be, then I know it's right. Okay, any questions on that? All right, so that's I think that's a good stopping place. So that's 7.2, just kind of some basics. Tomorrow we'll learn a little bit more about logs, mainly how we can combine them together if they're separate. Okay, so homework tonight is all evens. 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Now, I think in the homework, you're going to see some problems like this. And it's just going to say solve. And it's going to have an expression like that. And if you're like, well, wait a minute, where's the other side? All the problems he did in class had an equal sign. Well, if you're solving it and you don't know what it equals, you could just put equals something. Just put equal x. And now it'll look like the ones we did in class. Okay, so you got about 25 minutes. There's some extra books over there. So please use the time to get started. If you have any questions, let me know.